Hey Abby,
Hey,
what are you doing?
homework.
Well, you can't do homework anymore because this is when I interrupt you. I'm sure you'll be a good sport about it.
Yep, sure.
Because we need to play a game of, is this funny to a teenager?
Sounds good.
Now, I sort of half explained this to Abby, but maybe she doesn't fully understand the rules, so I'm going to just explain the rules and then you can do your homework later after we've had a bit of a laugh.
Sure.
So how this works is I have found a bunch of science cartoons and I've saved them on the iPad, and I'm going to show Abby the science cartoons one by one and we're going to watch her reaction. Now if she thinks it's funny like I think it's funny, then you get to see it. But if Abby decides it's not funny, then you will never see it. You'll never know what it was that I thought was funny that Abby didn't think was funny. You'll never find out. So it's a bit of a mystery. Now, to show it...
My opinion changes everything.
Does it? Yeah, it does. Even if I think it's hilarious. The worst is if I'm cacking myself laughing and you don't think it's funny at all.
Yeah, that would be
Embarrassing for me. Okay, so these are your options, Abby.
Alright.
This joke is hilarious. Ha ha ha. Teary eyes. Crying.
Oh,
If you start crying with laughter, that's the one you're going to pick. This one, joke's good, but not hilarious. That's this one. Have you had a good look?
Yeah.
That one. Now this one's like, not really funny, mum. I don't love that one.
Yeah.
That's the, not, yeah,
Yeah.
half there. This one is like, oh, why would you ever embarrass me by showing me this joke on the camera where everyone's watching? Okay?
Yeah, either
Right.
that or I don't get the joke.
Or you don't get it. Or I've got no idea what we're talking about. Okay.
Alright.
So, Abby, are you ready?
Yeah.
I've got the first one. This made me laugh even just before when I pulled it over. Okay, you ready?
Alright, I'm ready.
So I'm going to show Abby the joke. You're not going to get to see it unless she laughs. So, straight face. Let's start. Okay, we're going to start like this.
I don't have a straight face.
It starts like this.
What do you use?
Okay, you ready?
Oh, that's so bad.
I win. Come on, which one, Abby? I'm pretty sure we can all see which expression you've got on your face right now. That's your thinking music. Thinking music time. Quick.
Okay, I'm
pick.
thinking this one.
Wait, it was hilarious. Oh, but it's still, you get to see it because it's not a sad face.
Yeah.
Is that fair enough? They
Yeah.
see it if it's those two.
Yeah.
Okay, so I'll show you. Hello, grade 5-6. Nice to have you tune in again today. Now, last week we had a little bit of a look at yeast and respiration versus photosynthesis. And today I actually just want to get a bit geeky chemistry with you and show you how those two reactions happen, but with molecules. So I went up to school and I stole the molecule sets and I've brought them home and I'm going to build molecule reactions for you so you can have a bit of a look. Now this term I'll be teaching you about chemical reactions versus physical reactions, and I'm hoping by the end of the term you're going to know the difference between the two and you'll have done some experiments that demonstrate both. We've talked about atoms and molecules a bit at school, and I just want to show you what the molecules are that are in the respiration reaction that we talked about. It's a chemical reaction, and we break down glucose, which is a type of sugar, and we use oxygen, which we breathe from the air, and those two things, when mixed together in respiration, produce water, which we know as H2O, two hydrogens and an oxygen, and carbon dioxide, or CO2, which is one carbon atom with two oxygen atoms attached. Now this reaction produces energy, and we need this energy for everything in our bodies. But if you have a look at this equation, it's not like a maths equation where the left side balances out with the right side. There's more molecules on the left than there are on the right. So if we want to get technical and figure out why that is, it's because actually you don't just use one oxygen molecule for every glucose molecule for this reaction. We actually use 6 oxygen molecules and they mix together with one glucose molecule. And then out the other side, that then leaves us with 6 water molecules and 6 carbon dioxide molecules. Now, hopefully when you look at that, you can see that it's more balanced. All the same number of carbons are on the left and the right. The same number of oxygens are on the left and the right. The same number of hydrogens are on the left and the right. Sometimes I think of this a little bit like an anagram puzzle, where all the things that are on the left are also on the right, but they've been mixed up. And this is a chemical reaction. And that carbon dioxide that gets produced by yeast, that's what we use when we make bread to make it rise and be nice and bubbly. So let's do an activity now.
So it turns out that yeast is actually really hard to find at the moment in the shops. I've had another idea. Instead of buying yeast, we are going to actually grow our own and make our own sourdough bread in a couple of weeks' time. But this is going to require a lot of commitment from you, grade 5-6, because not only are you going to have to feed your little yeasty pets every single day, it might take a week or 2 weeks, and then after that you have to keep feeding. It's kind of like starting a group of pets, and you can't just stop feeding them halfway through. And then once we've got them growing and bubbly and they're producing lots of carbon dioxide, then we'll be able to use that to bake loaves of bread. So I hope you will do this with me. You need 2 ingredients. One is water and one is flour. I'm pretty sure we can all get our hands on some of that. And so over the next couple of days, I'll be doing this in my home and recording it, and then you can sort of follow along once I post this video. All right, without much further ado, I bring you sourdough.
For this, you'll need some flour. I used plain flour and wholemeal, but you can just pick one or the other. You'll also need a huge amount of boiled water over the next few days, so you can boil a kettle, put it in a jug, let it cool down so you can use it. And you'll need a big jar to grow it in. Now, I've done 2 cultures, but you can just choose one. You'll need a set of scales to measure the ingredients as you add them. And here I'm going to show you what to do. So you grab the jar, label it, and I think it's a good idea to write down in your science journal how much that jar weighs. Then what I'm doing here is I'm actually weighing 50 grams of flour into that jar. The same amount of water is needed, so you get your boiled water and add 50 grams of water as well. Then you just give it a good stir, so it's kind of thick. It's not quite like peanut butter, but it is quite thick when you finish with it. And then you basically just leave it on the bench until tomorrow, and the yeast will start to grow in there. Now you can see I've put a rubber band around the jar at the level of the dough. This just helps you to track the rising of it over many days. Now over the next couple of days, this is going to start smelling revolting. So don't be scared. These are some pictures of what mine looks like. Look at that. It looks so foul, but just keep at it because this will actually become something amazing. Now on the next day, 24 hours later, you start to see little bubbles forming, and you can see that in this. It will smell really bad. But then on the 3rd day, after 48 hours, you need to give it some food. So here I show you what to do. I've got my jar here and I'm weighing it, and you can see the rubber band and you can see how much it's risen. It's almost twice as big as it was when I first made it. I'm just writing down how much it weighs. Now they recommend that you remove half of it. So work out how much weight you've got in there. Take out around about half of your mix, and then you're going to feed it again. Because if you just keep adding food, it gets bigger and bigger and bigger every day until your jar is overflowing. So I'm taking out half right now, you can see that. And then I'm going to add in the same amount of flour that I did on the first day. And the same amount of water again. This is just a reminder that you need to feed it every day at roughly the same time. 50 grams of flour and 50 grams of water. After about 7 days, it should be all bubbly and ready to go. Give it a stir and move the rubber band to the new height, and then you just leave it again for another 24 hours. It's actually a really good idea to set an alarm on your iPad or phone to remind you to feed it every day. Now, yeast does this really cool thing. If there's no oxygen, yeast actually breaks a glucose molecule down into something else. So not only can it do normal respiration, but yeast, when there's no oxygen around, will turn a sugar molecule into ethanol, which is a type of alcohol. This is why your sourdough starter might begin to smell a bit like beer, because yeast produces alcohol when there's no oxygen. It also keeps producing carbon dioxide, so you can still get bubbles and turn it into bread. So don't be too surprised if your yeast smells a bit like beer. It's still going to work just fine.
Here I have a picture of a Pacific sea star. You can see that my drawing has improved dramatically in the last week. I think I spent 30 seconds instead of the 20 seconds I spent last week. So Pacific sea stars, they're actually not from Australia. They come from overseas in Japan, but they were introduced to Australia. Now we think that they probably got here in the bottom of ships and things like that. So I've drawn a beautiful picture here of a ship for you. And I don't know if you know this about ships, but when ships come, if we send a ship to Japan, for instance, with a whole bunch of boxes and birthday presents and important things like that, then that ship goes over there, drops all the cargo off, but it might not come back with the same amount of cargo. And ships have to have a really heavy base to them so they don't tip over, or when the wind and the waves come. And so what they do to keep that ship heavy is they actually fill it up with water from the ocean at the port that they're staying at. It's called ballast water. So let's picture this ship went over there to Japan, dropped all its parcels off, birthday presents and all, filled up with some water in the bottom of the ship to make it heavy again, and then came back to Australia. This is exactly what happened. But inside that water that they collected from Japan, there were some Pacific sea stars. Now they might not have been the whole adult star or something, it could have just been like a baby or something like that. And the Pacific sea stars got into the Australian waters and just started eating shellfish, scallops, all the things that we didn't want to die, basically, that we try to grow. And because they're introduced, our species weren't used to them and they just got eaten up. Not good for our environment. So in the 90s, this pretty funny thing happened. Scientists and lots of people went out there and collected up as many starfish as they could from the ocean because they were going to kill them. But do you know what they did to kill them? This bit cracks me up. They got the starfish and they chopped them into pieces. And then they just threw them back into the ocean. If you know anything about starfish, you might know that starfish can regenerate or grow back from body parts if a bit of the central kind of part of the starfish is there, called the radial disc. And so when they threw all these little pieces of starfish back into the ocean, which was, a lovely thought, they ended up with millions more starfish than they'd had before. So it kind of didn't really work. And the reason I'm telling you about this is because science doesn't always get things right. And sometimes we do talk about this at school. Sometimes by making those mistakes, that's when you learn stuff. That's when you think, hold on, cutting starfish into pieces and tossing them back into the ocean isn't going to get rid of the starfish. In fact, it might increase the numbers. We need to think of something else. So I guess I've been kind of thinking, well, what else can you do? How do we get rid of the Pacific sea stars from our oceans now? Why don't you have a little bit of a think about that too?
Last week on Science in Legoland. "430 Whitehorse students radioed in to help Danielle and Sunny solve the mystery of the skull. These were some of the responses. Just as Danielle and Sunny were discussing which of the 430 students might be onto something, a giant creature scurried past. Both minifigures screamed, "Ah!" Following behind the creature came a very old man.
Sorry about that. That was just my pet rat. Ah, I see you found my old dead rat's skull. I keep it here as a reminder that all vertebrates have skulls.
Right, and that's not creepy at all. And with that, the mystery was solved. Did you guess the creature correctly?